All right, welcome everybody. We are the SME NSSGA Senior Design Competition Team. We are team number 21070. We are very excited to show you guys our design for the design competition ran by the Society of Mining, Metallurgy, and Exploration, as well as the National Stone, Sand, and Gravel Association. I'd like to take a brief moment to introduce ourselves. I'm William Peterson. We also have Nick Overlees, we have Nathan Sires, we have Alex Contreras, we have Ryan Amos, we also have Sarah Huggins-Hubbard. These are our respective emphases within the mining engineering department. We are all mining engineering majors other than Sarah, who is an engineering management major. We're very excited to share with you our design. I'm going to toss it off to Alex, and she's going to talk to you a little bit more about the competition itself and show you guys what kind of structure we're looking at in terms of competing in the competition. Go ahead, Alex.
Thank you, Will. So as Will was saying, we did compete in an international design competition. This competition was conducted in 2 phases. The first being a 4-week phase during the fall semester. Throughout this phase, we were given 4 weeks to basically develop an economic and operations plan for a 20-year study of the Greenback Quarry in Tennessee. This operations plan, we were given 2 different options that we will talk about later, but I will continue on to talk about how the second part of this competition. So in the second phase, we were lucky enough to be able to compete, and only the top 6 teams get to compete in the second half of this competition. So in the second half, we were given an alteration to the original project description, and we were given 3 days to come up with our solution to that problem description and then present it in front of the judges. So next I'll pass you on over to Ryan to talk about our methodology for the competition.
Thank you, Alex. So one of the largest tools that we used throughout this competition was Hexagon's Mine Plan 3D software. To start off the competition, we were given some drill hole data that we needed to use and analyze in order to make some design decisions for the project. In figure 1, you can see an image of these drill cores that were taken from the site and some actual samples. So once we had this data, we converted this into a digital format so we could input this into the software and use it to create a visualization of the geology. Once we had this geology visualized, we were able to use it for 3 main features of our design. The first of which being our mine sequencing. In figure 2, you can see some solids of our annual tonnages that we expected to extract according to our mine plan. In addition to this, we also use it to design a haulage plan in order to determine some times it would take to go from the pit to the drop-off location. And finally, to design a final topography, including our pits, so we could use that for reclamation later on. Next, I will hand it over to Nathan to discuss some of the results of our design components.
Thank you, Ryan. And now with our data in a more usable form that we can put into our softwares and understanding our geology, we can finally try to tackle the question that was posed to us of what should the Greenback Quarry do? So we have 3 options. We have 2 that were given to us. The first being that the Greenback Quarry only mines out the existing pit. The second option being that they create an entirely new pit and reclaim the old pit. And our third option, which was our original design, was that we do a hybrid option where we exhaust the reserves in the old pit before moving to the new pit. As you can see, option 1 resulted in a 7-year life of quarry. Option 2 resulted in a 20-year life of quarry. And option 3 resulted in a potential 62-year life of quarry, with a kind of combination of option 1 and option 2. I'm now going to pass it along to my colleague, Sarah, so she can talk about some of our economics behind our project.
Thank you, Nathan. All of our financials were based off of a 20-year quarry analysis of the project, except for option 1, which was only extended to that 7-year mark due to the limited quarry life. Our financial metrics are shown in the table below. Option 3 was chosen with a net present value of $3.1 million and a 22% internal rate of return. This option was chosen because of the growing market as well as the long-term mining capabilities, even though the net present value is lower than that of option 1. The annual cash flows are shown in the graph, and the white line displays our net income. The annual revenues were calculated from the selling prices of the quarry products and the annual tonnages, while the expenses are made up of debt structure, equipment maintenance, and employee-related costs. Lastly, our team ran a sensitivity analysis on the diesel fuel prices, potential coverage of transportation costs to our buyers, and material selling prices. What we found from these sensitivities was that even with a 10% downshift in the market, this production and operational plan should remain profitable. Next, I will turn it over to my colleague Nick to discuss our design approaches.
Thanks, Sarah. So within this project, we have a few key design approaches that we really think help set us aside from the competition. The first being the innovative mining sequence, which was that combination of option 1 and option 2 to create option 3. The second one being our competitive selling prices of the products. Through that sensitivity analysis, we determined that we could cover up to 12% of the transportation costs. And lastly would be the reclamation plan. Our reclamation plan consisted of a butterfly sanctuary. This sanctuary has 4 different greenhouses containing over 6,000 butterflies, as well as fountains, and it was all revegetated with native species, as well as the pond was stocked with native species. The reason this stands out is because it serves as an economic boost through tourism for the local economy, and it also serves as a long-term source of income for later on. Next, I will pass it off to Will with conclusions.
Thank you very much, Nick. It was very exciting being able to compete in the competition. And we are more than excited to announce that we won the competition, beating out the likes of Colorado School of Mines and Virginia Tech. This is the first time that the University of Arizona has won the competition, and we are very excited that our unique design approaches were able to push us over that hump. Couple of our references, some of our references are listed here. Specifically, CostMine was very, very helpful in terms of coming up with some of the calculations for our cost models, which Sarah mentioned. And we'd also like to take a brief moment to thank our sponsors for helping us accomplish our goal of winning the competition. Thank you very much for your time. We really appreciate your attention, and have a nice day. Thank you.